Welcome to This Explainer. Today, we're tackling how to make complex, multivariable decisions without, getting totally lost in heady mathematical jargon. Have you ever just stared at a spreadsheet full of options? Maybe you're hiring a candidate, buying a house, or picking a software vendor, and you just felt completely paralyzed by all the competing data? Yeah, you're definitely not alone. So, we're going to look at a mathematically beautiful way to solve this exact problem. Right? Let's dive right into this. We all face these daily dilemmas with competing variables. And today, we'll discover how a highly intuitive mathematical concept solves this major pain point. Because in the real world, the perfect option rarely exists, right? The car with the absolute best gas mileage might literally have the worst safety rating, or the most experienced job candidate might demand a salary way outside your budget. So how do we systematically find the best possible compromise? Well, that is exactly what we're going to calculate today. So here's a quick roadmap for this explainer. We're going to cover 1. The complex decision dilemma. 2. What is TOPSIS? 3. The 5 calculation steps. 4. A real-world case on recruitment. And finally, 5. Modern TOPSIS web calculators. Okay, let's jump right into section 1, the complex decision dilemma. Decision scientists have literally spent decades analyzing multi-criteria decision-making, or MCDM. But traditional methods often force you into a really tough compromise. Older methods, like the weighted sum model, well, they're just too simple. They basically multiply scores by weights and add them up, which falsely assumes all your criteria are measured in the exact same units. You're basically adding apples and oranges. But on the other end of the spectrum, you have the analytic hierarchy process, or AHP. It's incredibly powerful, but it requires exhausting pairwise comparisons for every single variable, plus checking complex consistency ratios. It's totally mind-numbing. We really need a framework that's robust, but also easy to grasp. Which brings us to section 2. What is TOPSIS? And this is perfectly where our solution sits, right in that mathematical sweet spot. First developed back in the early 1980s by Yoon and Hwang, TOPSIS is an elegant geometric approach to decision-making that relies on a brilliantly simple spatial metaphor. Now, the name itself is a bit of a mouthful, technique for order of preference by similarity to ideal solution. But if you break it down, it tells you exactly what the algorithm is doing. It's ranking your preferences based on how similar they are to absolute perfection. So the really crucial point here is that TOPSIS frames the problem by comparing every single option against 2 hypothetical extremes, the perfect ideal and the absolute worst anti-ideal. Imagine a hypothetical super option that takes the best score from every single category. That is your ideal solution. Now, imagine an absolute nightmare option that combines the worst score from every category. That's your anti-ideal solution. TOPSIS basically argues that the best real-world choice should be as close as possible to the superhero and as far away as possible from the nightmare. This is such a brilliant core philosophy. We simply calculate the Euclidean distance, which just means drawing a straight line between 2 points, to find the alternative physically closest to the best point and furthest from the worst point. Think of it like plotting your options on a grid. One alternative might be physically closer to that top right ideal solution star and further from the bottom left anti-ideal point, compared to another alternative. It takes abstract data and translates it into physical geometric distance. Moving on to section 3, the 5 calculation steps. Now, how do we actually plot these abstract ideas on a geometric plane? Don't let the math intimidate you here. These 5 steps just take raw data, standardize it, weigh it by importance, measure the geometric distance, and then spit out one final clean score. Step 1, you gather your raw data in a matrix. Step 2, you normalize it. This just means converting all those different units, like dollars, years, and test scores, into a non-dimensional scale so they can actually be compared fairly, apples to apples. Third, you multiply those standardized scores by the weights you've assigned to each criterion. Fourth, you calculate those Euclidean distances we just talked about. And finally, step 5, you determine the overall closeness. Let's see this in action. Section 4, Real-World Case, Recruitment. We're going to apply this to a brilliant case study using a highly relatable scenario, hiring a new principal assistant. We have 4 candidates, Anna, Tom, Jack, and Emma, and they're being evaluated on 4 weighted criteria. Now, for this international role, the company is heavily favoring living abroad at 40% of the decision weight and the written test at 30%. Interpersonal skills only hold 10%. And as you can see, the candidates have completely different strengths across the board. This is our candidate dilemma, and it's incredibly hard for a human to intuitively balance all these competing variables perfectly in their head. Anna has great written test scores and solid experience. Jack knocks work experience completely out of the park with 12 years, but he has the lowest time living abroad. Emma has a massive 11 years living abroad, which we know is heavily weighted, but she actually has the lowest scores in both interpersonal skills and work experience. If you just guess here, the nightmare of hiring the completely wrong person becomes very real, mostly because our inherently biased gut feelings tend to take over. But by running our 5 mathematical steps, TOPSIS calculates the exact geometric distances and generates a clear similarity index for each candidate. When you use decision software like Discerns, it literally lists the distance to best and distance to worst for every single option, and then combines them into one final similarity index. And Emma emerges as the winner. She gets a final closeness coefficient of 0.630. This is a clean metric between 0 and 1 that proves she is mathematically closest to the ideal profile. Because that living abroad criterion was weighted so heavily at 40%, Emma's exceptional score in that category pulled her closer to the geometric ideal than Jack's massive work experience could for him. Anna comes in second with 0.610. The absolute beauty of this number, this closeness coefficient, is that it approaches 1 the closer an option gets to the absolute ideal. It completely removes the guesswork. Which leads us to our final section, Section 5, Modern TOPSIS Web Calculators. What is truly fascinating about bringing this dense mathematics into the modern software era is that you don't actually have to calculate Euclidean geometry by hand anymore. Because it relies on basic matrix operations rather than complex loops, TOPSIS is incredibly friendly for modern web architectures like React or pure JavaScript. Our source text highlights that compared to other methods that require advanced optimization loops, TOPSIS is beautifully streamlined. A standard web browser can run these calculations instantly without freezing your screen, which makes it the absolute perfect candidate for interactive online tools. A modern web tool handles all of that Euclidean geometry instantly. It automatically normalizes your weights and even exports the data directly to your spreadsheet or LaTeX document. You can literally just type in raw weights like 35 and 20, and the software will auto-normalize them down to relative fractions that sum to a perfect 1.0. Plus, if you're writing a research paper, these tools can export pristine LaTeX code blocks, CSV files for Excel, and even portable JSON states so you can save your workspace and easily share it with your colleagues. Ultimately, these lightweight web implementations mean you can harness the full power of advanced multi-criteria decision-making without writing out a single equation by hand. And honestly, it is a massive relief. Plus, the educational dashboards built into these modern calculators often show you the exact arithmetic happening live, step by step, so it never feels like an untrustworthy black box. You retain complete visibility, but the software just handles all the friction for you. Which leaves us with this final thought for today. The next time you face an impossible choice, will you trust a flawed gut feeling, or will you calculate the exact distance to your perfect ideal? We've seen exactly how TOPSIS transforms stressful, multivariable dilemmas into clear, mathematically sound rankings. By utilizing this really elegant spatial metaphor, you can confidently defend your choices, whether you're in the boardroom or just organizing your personal life. Thank you so much for joining me for this explainer, and I truly hope your next big decision is a little bit easier to navigate.